Good evening, my dear JEE warriors. Welcome aboard, all the amazing students. This is your Captain Shreyas, and today is Friday. And today is the day where we challenge ourselves towards the weekend for some amazing questions. Just a couple of days back, we had an amazing session of NSCP PYQs. And upon request, because you guys DM'd me, you guys asked for it, that's why the JEE Advanced top amazing tricky questions. I mean, when I say tricky, we are going to give you the tricks, and trust me on this, the tricks are really going to be mind blowing because we have none other than Vikas Sir with us, the Ekalavya teacher. So welcome aboard, Vikas Sir, on the Vedantu JEE English channel again. Nice to see you back again.
Thank you, Shreyas Sir, for having me here. Hi students, good evening. And today we'll be covering some nice things in front of you.
Yeah.
So,
and the title, if you have seen, it says that what you don't know in Ray Optics. Okay.
yeah, so students, I promise this to you that you might have completed this chapter in your batch, whether it is at school or whether it is in any coaching institute. But there are aspects about this chapter that you most probably,
Yeah.
you haven't seen it yet. And today I will show that to you, and we'll do it all without mathematics. It will be a totally mathless session, I would say. So totally on physics we are going to rely, and hopefully you are going to love it too.
Of course, sir. Of course. So I hope you guys are ready. And if you have not yet liked the video, please like the video right away, right now. And subscribe on the #1 JEE English channel in the country. We are soon going to be 3 lakh subscribers, maybe by next week. So guys, you have to be a part of that final 3 lakh journey in case you are not yet subscribed. Come on, push it up. Okay.
3 lakh is an enormous number, sir. That's
Yes.
a great number. So I must congratulate you, and I must congratulate all the students also
Thank
who
you,
are
sir.
very much responsible for this
Yes.
great achievement that is about to happen.
Yes. All right. So let's begin with the first question, which is going to come up. And sir, I usually have this doubt.
Okay.
And I got this doubt from many kids. But I want to hear it from you, the solution, or we'll talk it. It's going to be a conversational. Okay. I'm going to be like a student only. So, let me ask the kids also.
Yeah.
If I take an object at infinity, let's say we have a convex lens or something, and we have some kind of an object which is there at infinity. So usually we say that the rays will converge and we will get a point image at the focal point. Is that true, my dear students? For an extended object, we should get a point image.
So basically, let me ask this question to all the students. So guys, you have studied lens formula. I also know that you know the magnification formula in the case
Yes.
of lens. So in case if we keep an object at infinity, then according to your understanding, can you tell me the size of the image? Can you comment on the size of the image? I know what you guys are going to answer, but I want you to commit to an answer right now in the chat.
Sabri
Okay.
saying true, sir.
So-
okay, what about others? Syamla, Pravi.
So I hope you got my question, everyone. The object is at infinity, and we are talking about, let's say, a convex lens, and we want to know that what will be the size of the image. Small. Okay. So when you say small, Sabri, do you mean extremely small, like a point size image, or are you imagining something finite?
Something like small but finite.
So finite or infinitesimal? Let me.
infinitely. Yeah.
Okay.
So that will be interesting.
Students are smart enough. They are giving diplomatic answers. They are not
Small,
committing. They are
yeah.
not committing to a situation. So normally, what would you think? Okay, think about the ray diagram. Somebody must have shown you a ray diagram where they said that the object is okay, very far away
Yeah.
from this, and therefore, and object is.
Usually, I think this is what they do. Ray diagram. They will draw one ray like this. Oh, sorry. I think they will show that one parallel ray will meet at the focus. And again, they will show, okay, one more ray we can show. And again, it will come at the focus and one point image will be formed. Something like that.
So basically, I'll erase this one. So basically, generally what happens is that the student go by the magnification formula, V by U, and if the U is at infinity, magnification turns 0. So the height of the image turns to be 0. That is, you agree with, somebody says point. So do you agree with this logic, everyone, that if the height of the object, if the distance of the image of the object is at infinity, so m will be 0, and therefore most of the students give 0 as the answer. Okay. While in most cases this would be the right answer, but let me give you a situation. So let's talk about sun. So sun is an object which we can consider to be very, very far away from us. And if I take a convex lens and if I try to get an image of a sun on a screen, okay, so first of all, where will I keep that screen?
At the focal plane.
At the focal plane. So we know that we are going to get the image at the focal plane in this case. Okay. But what will be the size of the image?
I don't think it will be points. Sir.
That is the question.
Then think about it, like even if I say there is a moon, there is a sun, there is some mountain behind, every time I'm going to see the same infinitely small point image, I don't think that will work out.
Yeah. So you are absolutely right, sir. So here are a few things I want to highlight, and this is something that I want to explain. Or again, student, think about this. Think about this. If you are trying to draw the image of a sun, okay, image of sun in a convex lens, think what kind of ray diagram would you want to draw. I bet on this that you will not be able to draw the right ray diagram. I can bet on this.
Yeah.
100%, 200% sure that whatever ray diagram you are drawing right now, that is not the correct one.
And by the way, this question has also come in JEE Mains. It has started trickling down to JEE Mains. Actually, it's a good JEE Advanced question.
Yeah.
But now I think even bids and other exams will start asking this.
Okay, so to highlight what I'm trying to ask, think about this. All the students, you think about this. This is, let's say, the optical axis of a lens, and this is where we keep a lens. Okay, now think about sun. Okay, sun is extremely distant, and let's consider sun as a giant disk. Okay, ignore the size of the lens here. Ignore the size of the lens. The distance here. Okay, this distance is actually very large. So if so I'll show this to be a broken axis, indicating that the distance is very, very large. Now, if I draw the focal plane, we know that the image of sun will be in the focal plane. I ask you to draw a ray diagram in this case, and that is what I want you to do. But I'm very sure that you will not be able to do. Let me tell you.
Can you show what students usually draw, sir, so that they will...
I'll tell you what usually students are not able to draw. They try, they fail. Okay, and it's a good thing that they don't draw, because what they would be drawing would be the wrong thing. Usually in books, what is given, I'll show you. One ray is drawn like this.
Correct.
One ray is drawn like this, and an image is made like this. This is the usual thing that students find in the book, and that is where everything goes wrong. That is because of this diagram, the students are most times they're mostly confused. Like there is so many things which is wrong in this diagram. There is some, for example, when a student sees this diagram, the student will question, that we study that rays coming from sun are parallel beam. It doesn't look like a parallel beam.
Parallel beam, correct.
Where is the parallel beam here?
Correct.
Okay, I don't see a parallel beam. Okay, and then the object is at infinity. The image should be of 0 size, but we are getting an image of finite size. What is wrong? What is going on here? Okay, so this diagram actually is the one which confuses all the students. They see it in school books, and then they get confused. Right. So what is the catch here? Like, what exactly happens? Let me tell you that. So how do we explain this?
Okay, you want to draw a fresh diagram, sir?
Yeah.
Okay, I'll just draw it. Meanwhile, you can keep talking.
Okay, so guys, if I ask you that a parallel beam of light, okay, a parallel beam of light is passing through a lens, where does it converge? Okay, what would you answer? A parallel beam of light is passing through the lens, where does it converge? Okay, so can you answer this question, everyone? A parallel beam of light, where does it converge? Okay, where does it converge? A parallel beam of light, where does it converge? Okay, Sasi Kumar is saying a focus. Now, Sasi, it would converge at focus if I also mentioned that the parallel beam of light is parallel to optical axis also. Think about this. If I would have mentioned that the parallel beam of light is parallel to optical axis, then it would converge at the focus. But I only mentioned a parallel beam of light. Okay, which means that the beam of light could be coming like this also. It can be parallel, but it may not be parallel to the principal axis. So it could be coming like this. Now, such a beam will not converge at focus.
Yes.
It will converge in focal plane.
Right.
Okay, it will converge in focal plane. And where in focal plane? So the ray which passes through the optical center, we call this ray as the chief ray. Okay, we call this ray as the chief ray. So wherever the chief ray hits the focal plane, the other rays converge at that point, and this is where these rays are going to converge. This is where these rays are going to converge. So my question was, where does a parallel beam of light converge after passing through a convex lens? The answer is at a point in focal plane, not necessarily the focus. It would converge on focus if the beam would have been parallel to the optical axis. Okay, so it converges on the focal plane, and where in the focal plane, that you can identify by paying attention to the chief ray. Now, what is the chief ray? chief ray is the one which is passing through the optical center of the lens. It passes through the lens undeviated. So
Correct.
this is one of the key ideas that I would be using in my explanation.
Okay.
Okay, so that is one thing. So maybe I can write a summary of key ideas here. So the first key idea is that a parallel beam. I'll just write the keywords that can recall, that can help the students recall. So parallel beam converges in focal plane, at a point in focal plane. Okay. So that would be the first key idea. Now, what is the second key idea? Okay, the second key idea is that any extended object, okay, like a pen, is a collection of points.
Yes.
Is a collection of points, and every point is an object in itself.
Correct. That's
Okay.
how we should treat any extended
Yes,
object.
any extended object should always be treated like a collection of many point objects. And if the word point object doesn't doesn't resonate with you, or it doesn't clarify to you what we are talking about, I'll give you an alternative statement. Remember this: every extended object can be treated as a collection of small LEDs, point-size LEDs.
LEDs.
That this LED concept or this LED thought will help you to imagine that rays are coming from each and every point. An idea that we share when we study Huygens principle.
Correct.
Right.
Correct.
The same idea. Huygens principle also say the same thing, that in a wavefront, every point behaves as a point source. So that's what I'm talking about. That every extended object should be treated as a collection of many point objects, and each point object is emanating light of its own.
Infinite.
Okay.
Yeah.
With this idea, let's try to understand what will happen. And again, to understand what will happen, we'll have to look at the solar system also from
Different perspective.
by going out of the solar system. So to keep a relevance between the two figure.
Okay.
Okay.
Huh.
So let's say this is
Now you can proceed.
so let's say this is sun. As we draw when we are talking about the solar system, this something this mark came here.
It's okay, sir. Okay, we'll just use this symbol. Okay. Huh.
Okay. Now this would probably be Earth now,
Yes.
and this distance would be large distance. It would be a vast distance.
Correct.
And the lens is present on the Earth.
Correct.
The lens is present on the Earth, right? Okay. Now when we are trying to draw the image of sun in lens, which is on Earth, basically we are talking about the rays which are reaching the Earth.
Correct.
Which are reaching the Earth. We are interested in those rays. Now think about this. The sun will appear as a disk to us. Now that's a different matter. But this point, the sun is a collection of many points. This point will behave as an independent point source, giving out rays in all direction. Do you think that all the rays are going to reach the Earth?
No. All the rays will
All
not
the rays
reach.
are not reaching.
very
Rays
small
in a
portion will reach.
yes, a very narrow region will reach the Earth, and that too, if I don't talk about the entire Earth, if I talk about only my lens,
That is even smaller.
okay, that is, just think about this. Technically, the thickness of the line that I'm drawing here, even that is more.
Yeah.
Okay, even that is more. The ray belonging to a region which is narrower than that will probably reach my lens. So now tell me, guys, would it be a good thought to say that, okay, from here one ray is coming? Okay, and actually one ray, is something that you can consider as a collection of many rays. So it comes like this, but by the time it reaches our lens, okay, we start drawing it as a collection of beam, which we should. Whatever we are seeing as a ray here, the reality is that it is collection of many rays. So any ray you can split it as many times as you want. So even this ray can be shown as a collection of 5 rays which are parallel to it. This can be independently drawn like this. Okay, if we want to do that, we can say that actually this is this. This is the entire collection.
Within that thickness.
Yes, within this thickness. We can do that. Okay. So, so with this idea, what do we conclude, or where do we reach? What we are saying is that this beam is coming and it is becoming a parallel beam like this.
Beam of light.
Now think about the periphery, or from whichever point the ray is coming. Let's say this point. This point is again going to behave as an independent point source, and by whichever ray is going to reach Earth, by the time it reaches, it becomes like this. So going back to the previous
this will
figure.
also become parallel.
Yes.
Basically, not all the rays will reach here.
Yes.
So very few rays, by the time they reach here, it will be a small parallel beam of light.
Correct.
Reaching the lens.
Yes. Now this is a very subtle idea. So if you are not getting this idea, that's not your fault. The point is that no one has given you this deep an explanation till date.
Correct.
Okay, you're coming from this place.
Right.
They convert into a parallel beam like this, which converges here. Okay, as I said that a parallel beam converges in a focal plane. So this parallel beam will converge here, but the bunch of rays coming from tip of another parallel beam coming at a different angle, and this will make here. So like this, every point on the sun creates an image here, and therefore we get this image of a sun as the finite. Now, when you start thinking like this, every concept that you have studied, it conforms to the diagram. Like now everything seems to fall in place. It wasn't the case in the diagram that I showed.
Basically, what the books show then is only the chief ray.
Yeah, it's only the chief ray. Yes, it's only the chief ray. And technically, you know, this is the wrong way of showing. Like the two rays are coming. So, yeah,
what the stupidity of this diagram is, these two rays are coming from two different
objects.
things,
Yeah.
and how can they make an image?
Huh.
Because to make an image, you need two rays from the same object.
Minimum two rays we need from the same object. So we are completely missing that point here.
Correct.
Now that we have seen this explanation, we understand that, okay, this is not a ray, this is a beam. This is a beam that will converge at a point, and because it is passing through the
Same tan alpha or tan theta, you can say, is this radius by this distance, is also this radius by this distance, which is now easy to solve. That is, I'm taking for granted you will be able to do it.
So this is one of the key ideas that students miss. Okay.
Yeah. Oh my god. Just Durga, just try to refresh. I hope it will be fine. And if you have any doubts which follow up in the same concept, please ask. Please feel free, because we would love to answer any kind of doubts, and you will be surprised that suddenly you will learn something.
Yeah. The next thing that I'm going to talk about is something again that you are going to love. Again, no maths. I did not do any math here. I will not do any math now. Consider it as a challenge. Okay.
Sir, one student has asked one question: how moon shines through the sun? Moon is present on the back side of the earth. No, not necessarily.
No, that is not the case.
That has got nothing to do with this, but that is just the rays of the sun. Imagine Sir is the earth, I am the moon, you are the sun. Okay, so the rays are coming from there, it is falling on me, and some ray will get reflected, and it will reflect in all the directions, not like only in one particular direction. So those small set of rays which reach the earth after reflection from the moon is what you see as the full moon.
Kinetic Krish, you are probably an 8th or a 9th grader is what I understand. Most likely.
Sir, we have a lot of...
Actually, I would like to know if I'm correct or not. I've been watching a lot of Sherlock Holmes movies.
Okay.
And I like to do that science of deduction.
Is it?
Given his message, I want to, draw some inferences about this guy. So let us know whether my inference was correct or not.
Yeah.
Okay.
Okay. So what is the next concept?
Okay. Now, next is a challenge for you guys. And mind you, my first challenge is, it's like a starter. Okay, it's like a precursor. If you go through the first challenge, then comes the real challenge, that is the second one. So even the first one is not easy, but I expect, anyone who has been sincere with their studies of this chapter, they will finish the first challenge, which is again not so easy, but I trust you guys to do it.
Okay.
But the second one is something that will blow your mind. Okay. So the challenge is very simple, sir. This is
principal axis.
The principal axis. Let's say this is a point.
Okay.
And let's say this is another point. I'm deliberately drawing it away from, like, I'm making it very clear that one is more distant as compared to the other.
Okay. So guys, see this distance, right? This distance is this much. This distance is this much. It is a lot. Okay. So, fine.
Okay. Now you can treat any of these points as object. Let me do it for you. So let's treat this as the object. And let me declare that this is the image and this is the principal axis. Yeah, it doesn't matter.
Reversibility. Okay.
Yeah. Okay. Now the point is that this is an object. This is an image created by some kind of mirror.
Okay.
Point number 1, identify the mirror. Point number 2, locate the mirror. Where is it present? Point number 3, find its focus. And my questions have unique answers. That means if you tell to me
different,
you cannot declare that, sir, it lies to the left of O or it lies to. I'm not talking about the region. I'm asking you to locate it uniquely.
Geometrically.
Yes, uniquely, that this is where the lens, the mirror would be, not even 1 millimeter to the left of it, not even 1 millimeter to the right of it.
Now that I'm looking at Shivani's answer, I'm thinking about the second challenge.
What did she say?
She said convex. And I think Kinetic Krish, who's actually 12th standard student. Sometimes, sir, I think that curiosity still remains in 12th.
I'm wondering, how did it remain like till 12? Like
Till 12,
you did not get an opportunity to ask this question to any of the physics teachers earlier. That is quite amazing.
Okay, fine. Sabri, convex. Sir, I think this will be, getting even more fun because they have answered convex.
Guys, so, okay, guys, those of you who have given convex, let me tell you something. Take this question to whoever teacher, your school teacher or
any
whatever.
school teacher,
Then
anyone.
tell them, sir, we answered convex. They will scold you.
100%.
They will tell you wrong.
Yeah.
Then I will give you a way to prove them that you are right and they are wrong.
Yeah, correct.
Okay, like
But
90,
don't reveal too much, sir, then that second challenge
90% of the student will not answer convex to this answer.
Yeah.
100% of the teacher will say that convex is the wrong answer. Okay, but I will show you that you guys have given convex as the answer. We are going to make convex the answer now. We are going to change the physics to make that the answer.
Yeah, but maybe not the first time or maybe the second time.
Yeah.
Okay.
So guys, okay, my first question, you have to finish the ray diagram. You can use
show
a
where the
pencil.
mirror will come.
You can use a pencil and a scale. You can't make calculations. Like you can't say that, sir, I will measure this distance. I will calculate how much it is. Calculate how much it is. I will know the height of the image. I will know the height of the object. I will know the magnification. So that is not what I'm asking you to do. I'm asking you to make the ray diagram. Pinpointedly find out the location of the mirror and the pole. Like the mirror is the same as pole and the focal length and the center of curvature. So
Okay.
so
We have it. Guys, come on, figure it out. All right. So maybe they would have drawn, sir. So let's see what the students would do.
So, first of all, it is difficult to finish this. Okay. I'll just tell the right way to do it. So, guys, if you draw object, if you connect object and image. Okay. So, let me use the tool. Okay.
Yeah,
Is that
you
true?
can use this tool. Yeah, it's a line.
So, if we connect object with image,
Okay.
wherever this line cuts the principal axis, that is center of curvature. That is
That
sure.
is mind blowing. Can you analyze why this point is the center of curvature? What is the rule of that ray tracing? When a ray passes through the center of curvature, it will rebound back along that same path in the reverse direction. So wherever that mirror is,
Doesn't matter.
doesn't matter whether this side or that side, it will retrace back along the same line. If the mirror was here, it will again come back along the same line. So somewhere on this line, the center of curvature should be there, but the locus will be obviously where that line intersects the principal axis. Okay.
Right. So that would be one of the things that we can do. And of course, now we can extend this ray to whatever,
Infinite,
to whatever distance we want if we need. The second thing that should be done is that we measure this distance, whatever it is, and we mark another point at a same distance. I'm doing it, with estimation only.
Okay.
Okay. Similarly, you do the same thing here again. I'm doing it with estimation. Okay. I hope I'm getting it right. Okay. Does it look okay?
Okay, maybe.
Can we use any tool to measure the distance or can maybe copy?
I don't know, sir. It's
Okay.
little difficult.
Okay.
Okay. I think now it is looking okay.
Yeah. So because we are doing freehand drawing, so things may not be that fine. Okay. Now, join this point with this point and extend. Okay.
Okay.
So for this, I'll use the straight line.
Yeah.
I'll choose a different color.
Here only you can choose, sir.
Uh,
You can choose some different color. Okay, maybe you can choose purple.
This one I'll choose.
Okay.
Okay.
So we have difficulty choosing colors.
So we connect with this one and you extend it
Okay, we extend it till wherever it intersects the principal axis.
till wherever it hits. Yeah, that's the principle. That's the pole now.
That is the pole.
That is pole.
Okay.
Okay. How do we confirm it? So when you join this with this point, I think we did a fairly good job
Wow. Just
in hand estimation. That's amazing. So guys, one of the rules is that any ray striking the pole will move symmetrically with respect to principal axis. So we have ensured that, see this angle, whatever it is, okay, this is bound to be the same angle because of the geometrical construction that we have done. So now we are 100% sure that this is the pole of the mirror. Now this is pole, this is center of curvature. So that also,
the pole.
so that also makes it very clear to it that how I should be drawing the curvature. Okay, so the curvature will be drawn like this because the center of curvature is on this side, right? So the curvature needs to be like this. Now, It's very simple now. If this is the object, so this is your
Incident ray.
one of the incident ray, and this will become a reflected ray.
Guys.
Okay, and then the other incident ray can be this one, which will be reflected back, and that's it, guys. We are done with the diagram.
Wow, such an amazing weightage.
Okay, again, this was the first challenge.
This kind of question is also there, I think, in matrix, or I remember in JEE Advanced sometime some object and images are shown, identify
Yes,
the
yes.
mirror where it will
Yes,
be.
it is present in our Eklavya module also. Like,
Yeah, I have seen
from
in the
there
Eklavya
we made-
module.
yeah.
Yeah, correct. Guys, this kind of questions have come in JEE Advanced and it is there in the Eklavya module. What is it called? Name it. Some of you might know the name. Yeah, it is called JEE Advanced Rank Accelerator. Yeah, the best book for JEE Advanced. Okay.
so this was the first challenge. Hopefully, some of you did it.
This challenge, I am 100% sure many of the JEE teachers in the industry will not be able to do.
Probably.
Maybe.
Maybe, may not be. The second one is surely.
Second one, though, surely not. Yeah.
Okay, so what kind of object we had in this? Like, if we go by the ray diagram, this would be a real object.
Yeah.
Okay, and similarly, if I ask you to figure out the nature of the image,
Real image.
it would be a real image. Now, here is my second challenge. So,
Okay.
how did we start? We said that we have a line which we declared as the principal axis. Then there is an object point, there is an image point. This is how we started. Okay, if I give you the same line, same points, and you drew this diagram, as I promised to you guys that whatever answer you gave, we'll make it correct. If I ask you that I want to get the same image of the same object, okay, by the other kind of mirror. This was a concave mirror,
Okay.
okay, because this was the reflecting side. I want to get the same image of the same object by using the other kind of mirror. Will I be able to do it or not?
So we have to use a convex mirror now. So first thing you should be able to figure out, is there a possibility or not? Is it even possible to make a same image by the same object using a convex mirror? If it is possible, where that convex mirror is, that is the next thing to think about.
If it is possible, then I think the next question should be, is it possible only in this case? Like, is this a special case, or is it generally possible every time?
Every time. So
And if it is possible, then where should we keep that?
Where should we keep?
Okay, so first question, is it possible in this case or not? If it is possible in this case, is it generally possible in all the cases? And if the answer to these two is yes, then the third question should logically be, where do we keep that mirror?
Lens, a mirror.
Okay, so think about this, guys. This is an amazing thing to do. Again, most of the teachers would say that it is not possible. Like, I have seen this. Most of the teachers will say that, no, this object and this image you will get with the concave mirror only. There's no other possibility. But let me tell you that I'll answer this, guys. The answer is yes. It's a permanent yes. Every time, if you are getting a specific image of a specific object using one kind of mirror, you can always get 100% of the times the same image of the same object using the other kind of mirror. It is 100% of the times it is possible. And let me tell you this also, neither your mirror location will change, nor will your rays change. Whichever rays you have chosen to be incident rays.
Guess, guys, where it will be.
Okay.
Guess.
Whichever rays you have chosen to be incident rays in this diagram, the same rays will continue to be your incident rays in the next diagram. Whichever rays are your reflected rays in this diagram, the same rays will continue to be your reflected rays in the next diagram. So
maybe we can just show them what you mean.
We'll need some space on the other side. Can we shift the entire diagram?
Okay, we can't shift it, sir. Little difficult.
Is there an option that we can select everything and then we can move it as a group?
Okay, wait.
You explore that till the time I'll speak to the students. So guys, what I was saying is that 100% of the time it is possible. Neither the mirror change, like neither its location change, nor its center of curvature change. So the same mirror with the same curvature at the same location, with the same bunch of incident ray and with the same bunch of reflected ray, you get it every time. The difference, there is a difference though. Whatever was the nature of the object in the first diagram, the nature of the object in the second diagram will be opposite to that. For example, in this particular case, we got a real object. In the next case, that I am declaring that it's always possible. In that case, you will end up with a virtual object because here it was real. And similarly, in this case, we got a real image then in the next case, you will get a virtual image. But
Okay, so this was our actual first problem solution.
oh, we have shifted it. Great.
We shifted it.
So, sir, whatever I promised, I will exhibit that in front
Okay.
of the student now.
Okay.
Okay. So, I told you I will not change anything, neither the lens nor the neither the mirror nor the rays. So let's identify the incident rays in this diagram. If I'm not changing the curvature, how do I turn it into a convex mirror? Like it was a concave mirror. We'll polish on the other
Polish
side.
on the other side.
Okay, so let's polish on the other side. So we'll polish. Now, if I'm polishing on this side, you will say, sir, who sends light ray from the opposite side? How will it reflect? So of course, I will not send it from this ray. I will ask the rays to come from the opposite side. But mind you, I have said that I will not change the incident rays.
Yes.
So where are the incident rays? These two are our incident rays. Let me extend them. Oh, I got something extra.
It's okay. Okay, we'll use this same color. Okay.
So we'll extend this and this we'll extend this. So I'll draw a better one.
Okay, you will extend it, but the direction.
But I will reverse the direction. See, now what do we say? We say that object is intersection point of incident ray. So do we continue to get the same object? I'll make it dotted this time here.
Yeah, because it will not be real now.
Yeah. So intersection point of incident ray is the object.
It will
So
not be real.
so do we have the same object?
Yes.
Yes, we do. Now, you can check it out. You can use a little bit of geometry to deduce that if the ray is coming from this side, if this angle is theta, it will be reflected. So this was your one of the reflected rays. Now it will be reflected like this.
Wow.
So this is your another reflected ray. Okay. I think it went a bit inclined. Anyways, it's okay. And again, the ray which is coming like this, it is supposed to hit the center of curvature pass through. So it will just retrace its path. So again, the intersection point of the two reflected ray is this. So same image we are
Same
getting.
image will be found. Can you see both the rays are diverging? So we had to extend it backwards. So this is also again, dotted. This is not.
Yeah, this is now dotted. Yes,
Yeah,
this is now dotted.
this is also dotted. Yeah. So same image. It's
So-
mind blowing.
Same mirror. I mean, same location of the mirror, same curvature, same incident ray, same reflected ray. And why am I saying that we can do this 100% of the time? Because this is something that we can do 100% of the time. What did we do? We changed the polishing, we extended the rays, we reversed the arrows. You can do this 100% of the times. Okay, and things will be taken care of. So
Amazing.
I hope you got something nice today.
Yeah, this was mind blowing, sir. I mean, this geometrical construction can give them answers like this. Like I can think of questions only where the coordinates of the objects are given, the equation of a line is given, coordinates of the image is given, and locate where the mirror is.
Yes, where the pole would be.
Students will start using mirror formula, crazy and
Yes,
all.
yes.
That will no longer be needed. I mean, you just have to do one simple geometrical construction,
Yes.
tuck, you will get the answer.
Yes.
So that will be amazing, guys. Yeah, very good. Tejaswini, Sabri, everyone loved it.
Yeah, and guys, see that's I will say that's what the difference between JEE Main and Advanced is.
Yeah.
Main will probably talk about this figure, and Advanced will probably talk about the next figure by giving this figure.
Yeah.
Okay, that's the only difference. It's just the extension of what you study in
What you
mains.
study, correct.
Okay, we just take them to a deeper level, and that's where you need to attack. If you want to ace the JEE Advanced examination, this is the kind of clarity that you need in your thought. Calculation, speed, they are all byproduct. When you are conceptually very sound, okay, then you find the right methods, the shorter methods, and that is where you gain advantage.
Sir, one last trick we'll do.
Okay.
Maybe. And I think I remember yesterday only I was teaching them Ray Optics and I showed them a graph of U versus V.
Okay.
And usually students don't like it and many teachers even skip it. But I was like, no, I have to do it because it came in the exam. So U versus V graph is a hyperbola for concave convex mirrors. So there are some questions on it. Maybe we can do something on that.
Okay, sir. Again, I'll tell you that what sir, the topic that sir has mentioned, students face a lot of difficulty in that. I'll tell you what kind of questions. So, see, in Ray Optics chapter, there are some questions which will say that, okay, I have a focal length of this much. I'm using a mirror. The object is here. Where will be the image? Now,
Right.
that's a straightforward question. Like we put the values, we get it. But there will be questions like this. Some question will say, okay, select the correct statement. Another first statement would be something like this, that using a convex mirror, we cannot get a real and magnified image of a real object.
Okay.
Now, how do I answer this question unless I'm aware of all the
ray-
possibilities that exist with respect to a convex lens.
Okay, if it is at least real, it's okay. But if it is virtual, then it becomes scary.
Yeah. So how do I remember all the situation? Like usually what the students do, usually what the teachers ask the student to do,
Graph.
you probably either do it through the graph or you remember a table.
Yeah.
A table must be given to you that if the object lies between this and this, then the image will be here. The nature will be different. You know, you construct.
can you-
How many of you can recall that table? You comment on that. If you you may not be able to recall the table right now, but how many of you recall seeing that table? That there was a table that was shown to us, and you were told to cram up that table. So what if I tell you that I can make you learn that table right now, and it will be like a video that that you will develop in your mind. It will be like a mental video that you are creating for yourself. You play the video in your mind. It will take about 5 to 10 seconds, and the entire table will be in front of you. You can make that table like that. Okay, mathless. Everything will be completely mathless.
That's the best part today, guys.
Okay.
Today we are doing physics JEE Advanced questions without maths. Maths teachers are going to hate this lecture. Okay, amazing. Let's
So-
do this, sir.
Let's do this. Okay, guys. So it is going to be a bit time consuming.
No
And
problem.
whatever I'm telling you, we can do this for lenses also. We can do it for mirrors also. So both the lenses, both the mirrors, we can do. Let me take one example.
Okay.
Okay. So let's take the example of a lens maybe.
Okay.
Okay. Let's do it for convex lens. So if we are talking about lens, okay, to do what I'm asking you to do, there are few points that you have to always keep in mind. They are actually simple points. You already know them. I'm just saying that I'll be using these points in explanation. So you will be able to recall them, you know, that why I mentioned this here. So first point is that if object is at infinity, okay, if object is at infinity, where do we get the image?
Image at focus. Come on, answer in the chat box and smash that like button.
Okay.
Button.
So if object is at infinity, image will be in focal plane. Right now we can just write focus also. And this is the second focus. Since we're talking about lens, okay, we're talking about the principal focus. Object is at infinity, image will be at the principal focus. Second point that you have to keep in mind is that velocity of image parallel to optical axis and velocity of object parallel to principal axis, they have same sign always.
Correct. B square by U square formula.
Yes. Okay, which basically means that if the object is moving rightward, the image will also move rightward. Okay, so they have to move in the same direction every time. And for both the lenses, whatever points I'm writing, they are not specific to convex lens. They are for both the lenses. Okay. Third point, object and image. Where do they meet? In case of a lens, they meet only once. They meet only at one place. Where is that place? O and I meet only at
2F.
center of curvature. Yeah,
This.
center of curvature. Optical
lens,
center.
it will
Optical center. Yeah, optical center.
Yeah.
Okay, for lens it would be optical center. That 2F answer would be for mirror.
Mirror.
Okay, so I think this three should do the job for us. If we need a fourth one, I'll write it when we need it. Right now, I don't think that I'll need anything else to explain this. Just in case if we need anything, we'll add it to this list. Okay, so let's start, sir. So, okay. This is my optical axis. Okay, and this is my lens. Oh, I thought that the tool will be at play.
Okay. This you want to, okay. Want the lens.
Okay. Now, actually, there is one more point that we should have added. I remember it now. When the can we go back to the previous slide? So the fourth point would be if object is at if object is at 2f1, image is at 2f2.
Symmetrical, yeah.
Okay, so this is something that I'll probably want to show with a diagram, especially for a concave one. Convex, it is very simple. You keep the object here. Okay, you keep object here at this distance, like this point is 2f1. Okay, you get it at 2f2. That is very simple. Okay, for a concave also it is simple, but it is generally it doesn't strike the student. You know, so I'm just drawing it here once. So in case of concave, 2f1 would be a point like this, and the rays need to come from this side. Then we'll say that the object is at 2f1, and then this will be 2f2, and these rays will diverge to appear to be coming from. So that this is what we are talking about. Okay, so this fourth point is actually important point. Okay, now let's go back. Okay,
One student is asking, sir, please explain third point, object and image meet only at the optical center. What is optical center, guys? Basically the center of the lens.
Yeah, the midpoint of the lens. Okay.
Midpoint of the lens.
All right. So can we go? Okay. Now my plan is to assume that I have an object which is in the shape of an arrow, and I'll assume that it is very, very far away from our lens, and I'll gradually move it towards the lens, and we'll see that what happens to the image. Okay. So let's establish one thing. When I move this object towards the lens, okay, the arrow of the head of the arrow, it will remain on a straight line. Okay, so let me draw that straight line. So the arrow will always remain on the straight line.
Correct.
Okay.
Yeah.
Okay. The arrowhead. Okay. So if I consider arrowhead as the object, my object is moving on this straight line.
Correct.
Okay. Okay. Now this ray, imagine if this is the ray, then it will pass through focus after reflection. I'm just talking about one ray. So it is a ray parallel to optical axis. After focus, after reflection, it will pass through f2. This is through f2, let's say. Okay. So
Yeah.
okay.
Okay.
And can I draw another one?
Yes. Yes.
Oh, it will shift this one. This one. I'll again take it. Will it draw? Shifting the same.
Okay. Wait, I'll remove it. Now you can draw, sir.
I wanted that one.
Oh, you wanted that one. Okay.
Okay.
You wanted to draw one more.
Okay, I'll draw it like this only. I'll start from here. Does it look like a straight line?
Yeah.
Huh?
Yes.
Both of them look like a single straight line?
Yes, yes, yes. ठीक है. It's almost a straight line. Yeah.
Okay. Oh, yeah, it looks good. So basically, I'm declaring this yellow line as the object line.
Okay.
And this pink line, this purple line as the image line. So let's first be convinced here, because this yellow line will flow along this line.
100% always.
So if any point, if any object is located here, I can choose this as one of the incident ray.
Always.
I can choose this as one of the refracted ray.
Correct.
So the image has to lie on it.
Oh.
So the image of this arrowhead will be on this purple line only.
Always.
It cannot lie outside this.
Oh, nice.
Right. So instead of talking about object point and image point, this is an object line, and this is the image line.
So basically the image head will be always here, somewhere like this,
Yeah.
and it will be like this.
Yes. So
Always.
it actually, this kind of visualization also tells a lot about, if I give you a rectangle as the object, what kind of image can you expect? Okay. It will help you attack that problem also. So the image of this arrowhead is going to be here. Okay. Now it's very simple. Now it's very, very simple. If the object is at infinity, where are we expecting the image?
Focal.
At focus. So the image would be very, very small.
Right.
Diminished. Remember, this is a finite size object.
Right.
We are keeping it at infinity. So its image size will be negligible.
Negligible.
Those of you who will say that, sir, for sun you said that we'll get a finite size. Sun is a body of large dimension. It is a finite size object. So here, now sir, see. Now see the magic. If you shift the object rightward,
Slowly.
okay, the image will also shift rightward. It has to go rightward.
It has to go.
And by the time object reaches 2f1, during that period the image has go to 2f2.
Correct. So this will go like this. So you are saying this will go like this,
Yes.
like this, like this,
Yes.
till here. I'm
Yes.
already, people are, one student has already told, sir, I'm already able to visualize many
So
things.
as you are moving the object, so the object has moved from infinity to 2f1. The object has covered an infinite distance.
Yeah.
Okay, and the image has only moved from f2 to 2f2, which clearly indicates that right now the object is traveling faster and the image is traveling slower.
Very slow.
Okay, the object is farther, so object will have a larger size. We can see that the image is having a smaller size. Image is inverted, image is real.
Real.
Everything is very much visible to us.
Visible.
We are not calculating anything. We are not remembering from any table. Okay, all this is visible to us. Now, they are both here. They have the same size now. Okay, in our figure, it may not look like, because we have done freehand drawing, and that too on a board. On paper, I can still do draw better. Now, when the object starts moving further to the right, the image starts going further to the right. And as the object reaches the first focus, where does the image go?
Infinity.
The image will go to infinity. Now, that's troubling. The image has reached infinity. Okay.
What's beyond that infinity? It's
Yeah.
like there
How
is a-
will that move rightward now?
It's like the universe has a door, and you are going out of that door, and you are coming out from
Yes.
the other door.
Now, the moment you shift the object further right, the image needs to travel rightward, but where does it travel? It has already reached infinity, so it appears here.
This side.
Okay, it appears from this side and it continues its rightward journey. And by the time the object reaches the pole, the image also reaches the pole, clearly indicating the size, orientation, nature, and even the speed. Who is traveling faster and when. Okay, so this is all the possibility of real object that we have considered. Now, what can I conclude from this? A real object, in case of a convex lens, cannot create image in this range.
Yes.
It's visible.
Yes.
We have not calculated it. We have not used the table.
To create. Correct.
Okay.
Scary.
Got it. So now we can also continue our talk for virtual object as well. You know, if we want to talk about virtual object, you just extend this line and just continue on the same logic. As your object is traveling along this line, okay, the image also has to travel rightward, but when the object goes to infinity, the image should be at focus. So the image will just, so as the object travels from lens to infinity, the virtual object, image, which is a real image, goes from optical center to focus. So it is clearly seen that if my object is virtual and I'm using a convex lens, I cannot get image outside this region. Okay, and the image will definitely be real. It will be of smaller size. It will be erect. So all these things are visible now. Correct. All these things are visible. So
this is amazing, sir. What an technique this is. Like mind blowing. Like really, just one line here and one line here has made the entire visualization.
Now, if you repeat this in your mind 2 or 3 times, it's like you have learned the entire table that you are asked to learn.
Correct.
And you know there is so much more. You know, for example, that table doesn't talk about the speed.
Yeah.
Here you are getting the both of them will have the same speed when they are at the same distance. That is at 2f and at 2f2. Otherwise, you know that whichever is closer is traveling slowly.
And those tables don't give you the virtual object cases, by the way, most of the times.
Yeah.
And I think you should try it out as a homework for concave mirror, convex mirror, concave lens. Just try this out. It will be literally a opening session for you.
Yeah, guys. I hope you enjoyed this.
Yeah, and this is the kind of teaching which Vikas Sir does and his team does. This is, I think, probably 5% or 1% of what you guys do.
So, sir, techniques like this, it exists in every chapter. So there are 2 things actually that exist in every chapter. One are the concepts that are never discussed. Now, these are not the concepts that are never discussed, but these are the same concept that the students know, but they haven't used those concepts, as a tool, as a weapon to make better conclusions.
That is more important. Okay, today you visualize, but can you now apply it in a problem?
Yes.
Where is it used?
Yes.
That is important because a concept, okay, fine, tricks you can learn.
So basically, when we are teaching the student, there are 2 things we are trying to explore. One, we know that there are certain concepts that the student may not have been exposed to. We try to expose those concepts, the students to those concepts. And secondly, whatever the student know already, can we put it in a better way in front of them so that they are able to recall and apply during the exams when they need to.
Right. So, my dear students, there will be more lives like this. And of course, NSAP classes are also there for extending, your understanding. Plus, JEE Advanced PYQs we are doing on the channel. But obviously, that is not going to be enough. There is something more that you need to discuss intensely. And imagine Sir is right now in this YouTube. But imagine Sir sitting with you guys, along with Chandan Seni Sir, along with so many Sirs out there who have taught the Olympiad kids and personally mentoring you and discussing all your doubts. That discussion goes to another level. And that is what is going to happen in the Agrani Ekalavya JEE Advanced 2026 batch. Now, this batch is starting 21st September.
21st September. That's the date when the second version of the batch is starting. So guys, the batch details we'll share with you, but it's important to understand that Eklavya batch means what? It means a group of people, teachers and students, who are committed towards a single goal. And the goal is your selection into the IITs. Okay, the teachers are fully committed and only those students should join who are actually committed themselves, that they want to be in IIT, who are ready for the rigor, who are ready for the hard work, okay, who are ready to be, treated as students and not as customers or clients, in batch. Like, these are the batches where you will not find the teachers to be pampering you, to be, may I serve you kind of attitude doesn't work with these batches. Okay, I scold the student. All my colleagues, they scold the student when the student is at fault. If anything is good for the student and we feel that the student needs to be scolded or to be explained or to be guided, we do everything that is needed. So I think this philosophy is very much important, that this is a no nonsense batch where the entire focus is always on your betterment. It is always on driving the results. Okay, so it is important, these details, of course we are sharing it with you, but more than that, the intent with which this batch has been created, the intent with which the teachers teach in this batch, that is more valuable, and that is something that that should encourage you to be a part of this batch. The peer group is highly supportive because a bunch of like-minded individuals are present there who are always ready to help each other. So that is, I think, the main USP of this batch, of course. Okay, and if I explain this batch, so guys, on September 21st I will do an orientation where I will explain everything that we are going to do in this batch. I will share the content that you need to have, how to use that content, how we will be using that content. Everything will be told to you on September 21, and then from September 25 your classes will begin. We'll dedicate October, November, December, 3-month period. We'll dedicate for revision. It's going to be an 11-week period. In these 11 week, we'll have 6 week dedicated to grade 11th revision and 5 week dedicated to grade 12 revision. At the end of every week, test will happen. Paper 1, 2 tests will happen on Sunday. Paper 1 will be JEE main pattern and paper 2 will be JEE advanced pattern. All these tests are going to be part syllabus tests. So that is what your phase 1 is. During phase 1, there is an additional thing that we'll be doing. We'll be having 45 minutes of chemistry session every day starting from mid-November. This will continue till mid of January. So you'll be having around 50 sessions on inorganic chemistry. Inorganic plus organic chemistry, the part there where you need to learn. Okay, because I have seen that the students, they don't want to study inorganic chemistry. It is boring. It is boring. Most of the time they are reluctant to start it. So this is an effort to bring discipline in your chemistry studying. Okay, we'll study it as a group, so you will not find it boring. And just by being part of the session, you are going to learn a lot. And we have also been conducting tutorial classes. Now, what are tutorial classes? Many times the students have not prepared at the right level because of whatever reasons, being choosing wrong institute, not being very sincere in initial part of their studies, whatever reasons. So these sessions are meant for hand holding the students who are not even able to begin the first question. How do I begin? So during these sessions, the teachers will demonstrate that how do you start the basic questions. So these are kind of optional sessions that only the students who are finding to solve question very difficult, they should join. The teachers will demonstrate some question and hopefully the students will pick the teacher's brain and they will start also solving the same thing. So that is phase 1. Phase 2 is in the month of January, where we are going to have 25 JEE main full syllabus mock test. Okay, so every day a test will happen, and from February onwards we will embark onto our JEE Advanced mission, where we are going to solve the rank accelerator module and we are going to solve the Eklave ATS test series.
Sir, one simple doubt. A student will think, I will start from phase 3 only, JEE Advanced. This is also JEE Advanced. I will first see my JEE mains result and then start. I feel when a student is thinking like that, that means a student is doubtful about their preparation. So what is your suggestion, sir?
Sir, this program we are doing from 2019 and until last year, around 4 years back, we started preparing the student for JEE main also. Before that, we were always starting this course after JEE main. Okay, and the feedback that we got from the student was that if we would have come into contact with these teachers, with this system before our JEE main, even our JEE main percentile would have improved.
Correct.
And this was the sentiment. Now, what was the consequence of this? Because the student did not score good in their first JEE attempt, they were now, mentally they were committed to the second attempt also. They were not able to let go of JEE main and focus entirely on JEE Advanced.
Less time for JEE Advanced.
Yeah, so we identified that if we want our students 100% attention on JEE Advanced, then we have to solve the problem of JEE main as well. We need to ensure that JEE main is removed from their mind. And how do we achieve that? We make the students score very good percentile in JEE main attempt 1.
Makes sense.
So that they can, mentally be free of the attempt 2. We of course encourage the student to go and write the exam, because if I have scored a 99.9 percentile in JEE main 1, I will probably go for a 300 marks, 100 percentile in 2. I'll take a risk. If there are questions with the answer of which I don't know, we encourage the student to take chances. Okay, if their JEE main first attempt percentile is very good and the student is also now unburdened. Okay, the student completely focuses on JEE Advanced. So therefore, earlier we were only dedicating, we were starting the program during this period.
Now,
But to be able to achieve excellence here, we need the student to be free of the worries of JEE Main, and therefore we are starting at this point.
amazing, sir. And by the way, the price of the batch, it's very reasonable. It was 20,000, but after speaking to the management, and we have taken extreme cost cuts, guys, for this particular batch. It's just for 9,999 rupees, because the batch is going to start on 21st of September, the early bird offer, or else without the discount, it goes to 15,000 if I'm not wrong.
So, sir, that's absolutely correct. In fact, guys, again, because I've been associated with this batch since 2019, sir was also there in 2019-20, and then he turned into a YouTube thing. But before that, sir was also part of this entire program. So, historically, this batch used to be a free batch, historically. Okay. When we used to run it in the period of February to March, because that time the teachers were mostly free. The 11th and the grade 12 batches, they were busy with their school exams, so we were able to do that. Okay, now since last year we have made this program a 10-month program. That means it's a year-long engagement, and therefore sustainability has become an issue, and that's what we are trying to solve now. We are trying to keep the price to as low as possible. Last year we kept it at 15,000. Like we enrolled for 15,000. This year we are doing it for 10,000. If the program becomes, popular, the more students we get, the lower the prices will get. We are trying to make it, like, for us, Eklavya is not a business batch. It is a excellence batch. It is a no profit, no loss kind of a batch, where we have to ensure that sustainability is there, so that we can run this batch continuously year after year. And at the same time, we don't want the burden to be passed on to the students. So the idea is very simple. The more students we have, the more economical it gets for the student themselves.
Correct.
Having said that, we have tried to retain that element of the scholarship element. We have kept a scholarship criterias. Okay. When this batch used to be a free batch, we used to conduct entrance test, and we used to take students on the basis of JEE Main percentile. So there was still a barrier. The barrier was merit. The student need to perform above a certain merit to be a part of Eklavya, when it used to be a free batch. Now, although it is not a free batch, but we want to retain that factor. Okay, so any student who would be scoring above 98 percentile will refund their fees. 100% of the fees will be refunded. In case if you have bought the combo version where you get the hard copies, only the amount of hard copies will be deducted and everything else will be refunded. If the student score anything between 96 to 98, we'll refund 90% of the amount. If the student scores anything above 92, anything between 92 and 96, we'll refund 80% of the amount. So that element is still there for the deserving ones. Like historically, we have kept this program free for students who deserve to get the scholarship. That element is still maintained, but it is by the way of refunds. Okay. And again, I'll reiterate, the more students we get here, the more lower we'll be able to make the price gradually. Okay. I think our actions tell that what we are trying to achieve through this batch. And, I hope that you appreciate that. So,
and if you're in any other batch, you are still getting 10% instant discount as a refund, of course, the moment you join the batch. Okay, or even for a dropper student.
Sir, all the refunds are in the form of, all the scholarships are in form of refunds. Yeah. So if you are a current student of any batch, or if you are a previous Vedan, you can still join the batch. You will pay the same amount, but this much amount, 10% will be refunded to you, irrespective of the percentile that you are getting, on account of you being a previous Vedantu student.
Correct.
If you are a dropper student, again, you will get 10% refund. Even if you have dropped from any institute, or you were part of Vedantu, not part of Vedantu, doesn't matter. Okay, you will get 10% refund. Again, that is irrespective of your percentile. If you crack this one, then all others are not applicable. If you can't crack this one, then one of these will be applicable. Additionally applicable, apart from what you are getting right now.
Where do you join the Eklavya batch? The link is there in the description box. Open it up right now. You will see it and join it right away, because 21st September, guys, come on. It's there.
I'll see you in the batch, everyone. I'll see you in the batch.
Okay. So thank you so much. And we'll keep doing more such as JEE Advanced sessions and Olympiad sessions on this Vedantu JEE English channel. Okay. Thank you so much, guys. See you guys. God bless you all. Bye-bye.
Bye, guys.